Right, this is page 2 from our packet, or we called it Special Parallelograms Worksheet 2. All right, so the first one, we have to fill in the chart by putting checks in the boxes for everything that is true. So 4 sides, so quadrilaterals are 4-sided figures. So parallelograms, rectangles, rhombuses, and square, they all have 4 sides. They're all types of quadrilaterals. That's why if you look on your Venn diagram, right, your quadrilaterals property sheet, they're all inside that quadrilaterals box. Okay, we know that rectangles are parallelograms. We know that rhombuses are parallelograms and squares are parallelograms, right? That's why they're all called special parallelograms, because they're types of parallelograms. So that means that they have the same properties as a parallelogram. We know parallelograms have opposite sides that are parallel, so it should be true for all of these. Okay, we know parallelograms have opposite sides that are congruent, so it should be true for all of them. We know parallelograms have opposite angles that are congruent, so that's true for all of them. We know parallelograms have diagonals that bisect each other, so that should be true for all of them. Okay. From there, we can look at our special parallelogram cases, right? Rectangles, rhombus, and squares. A rectangle is a parallelogram that has 4 right angles. So it doesn't have necessarily all sides congruent, but it has all 4 angles congruent because they're all right angles. Okay. We also know that rectangles have diagonals that are congruent. Okay. All right, let's do rhombus. A rhombus is a parallelogram with 4 congruent sides. So we need to check that box off. Okay. And we know that the rhombus has they bisect, their diagonals bisect opposite angles, and the diagonals are perpendicular. Right. And then for a square, we know a square is a rectangle and a rhombus. So if it's true for a rectangle, it's true for a square. If it's true for a rhombus, it's true for a square. So a square is going to have 4 sides that are equal. A square is going to have 4 angles that are equal, right? 4 90-degree angles. If the diagonals are congruent for a rectangle, they're congruent for a square because a square is a rectangle, right? And then for a square, the diagonals are going to bisect the opposite angles, and they're perpendicular because a square is a rhombus, right? So if it's true for a rectangle, it's true for a square. True for a rhombus, true for a square. Okay. Yep. So all sides equal, that's a square and a rhombus. All angles equal, that's a rectangle and a square. Diagonals are congruent, rectangle and square. Diagonals bisect the opposite angles, rhombus and square. Diagonals are perpendicular, rhombus and square. Excuse me, square. All right, let's go to the next one. True and false. All quadrilaterals are parallelograms. So a quadrilateral is a 4-sided figure. Parallelogram is a 4-sided figure that has 2 pairs of opposite sides that are parallel. So if I can find a quadrilateral that's not a parallelogram, so for example, a trapezoid, right? There's a 4-sided figure that's not a parallelogram. So this statement is false. All parallelograms are quadrilaterals. Yes, a parallelogram has 2 pairs of opposite sides that are parallel. So it's going to have a total of 4 sides. So it has to be a quadrilateral. That's true. A square is a parallelogram. Yes, a square is defined as a parallelogram with 4 right angles and 4 congruent sides. So a square has to be a parallelogram. Okay. A parallelogram with a right angle is a square. So if we have a parallelogram, right, with 1 right angle, since it's a parallelogram, opposite angles are equal. So that's 90. And since it's a parallelogram, consecutive angles are supplementary. So 180 minus 90 is 90. 180 minus 90 is 90. So that looks like it could be good. But a square also has 4 congruent sides. So we're going to have to say false on this one. Okay. It should be a rectangle. It's always a rectangle. It would be a square if it also had 4 congruent sides, but we don't know that the sides are going to be congruent here. So we're going to have to say false. I might have tripped you up on how I worded that one, but basically a parallelogram with four right angles is a rectangle. A square is a rectangle, but not all rectangles are squares. So we're going to have to say false on that one, right? In order for a statement to be true, it needs to be true in all situations. Okay, but we could, this could be 5, 5, 8, and 8, right? That's a rectangle, not a square. So this is false. Okay, all rectangles are parallelograms. That's true. A rectangle is a parallelogram with four right angles. All rhombuses are squares. That's false. All squares are rhombuses, but here's a rhombus. 4, 4, 4. But most importantly are angles, right? You could have 60, 120, 60, and 120, right? There's a rhombus. That is not a square, so that's false. All squares are rectangles. That's true, right? Because a square has four right angles, which means it's a rectangle. A parallelogram with four congruent sides is a square. No, it should be a rhombus. It could be a square, but it doesn't have to be a square. It could just be a regular old rhombus. Then a parallelogram with perpendicular diagonals is a square. Again, that is false. Right? I think I might have screwed one up on my other handout. No. Okay, we're good. But again, those should be rhombuses, not squares. They could be squares, but they don't have to be. They could just be a rhombus. All right, rectangles. So we know rectangles, all four of these triangles are isosceles triangles. So this is 24. This angle down here, angle 1 is 24. And we know the corners have to add up to 90 degrees because they're right angles in the corners. So 90 minus 24 gives us 66. Since this is isosceles, we'll have 66. These need to add up to 90. 90 minus 66, 24. 24. 66, right? It's got to add up to 90. And it's isosceles, so 66. And then these add up to 90, so we're good. All right, three angles of a triangle add up to 180. So 180, excuse me, 9 minus 24 minus 24 gives me 132. And start using the text tool. Nope, actually not going to do that. 132. Vertical angles are congruent, so this is 132. And then I can either do 180 minus 132, or I can do 180 minus 66, which gives me 48, 48. All right, the rhombus. We know the diagonals are perpendicular in a rhombus. So we know all of these angles here are going to be 90 degrees because the diagonals are perpendicular. We know the diagonals bisect opposite angles. So angle 9 here should be 36 degrees. Since opposite angles of a parallelogram are equal, it's going to be 36 and 36. And then we know the three angles of a triangle add up to 180. So 180 minus 90 minus 36 is going to give us 54. So 54, 54. And then opposite angles are equal, so 54, 54. A square is both a rhombus and a rectangle. So since it's a rhombus, we know the diagonals are perpendicular. We also know the four angles of a square are 90 degrees, right? Four right angles, because a square is a rectangle. And we know the diagonals that bisect those right angles. So we know each of the small ones are 45, right? 90 divided by 2 is 45, because those diagonals bisect the opposite angles, the angles in the corners. And there you have it. We got all of our angles. All right, 21. Now the rectangle So on this one, vertical angles are congruent, so we're gonna do 116. Linear pairs add up to 180, so 180 minus 116 is 64. 64. Okay, we know again that these four triangles are all isosceles. So we know that these two angles, the base angles of each triangle is they're congruent. So I'm gonna do 180 minus 116, which is gonna give me 64. And then I'm gonna cut that in half. 64 divided by 2 is 32. So we should have 32, 32, and then 32, 32. Okay, we can also do the same thing for the other one here. 180 minus 64 is going to be 116. And then split that in half, divide by 2, gives us 58. So then these angles here, 58, 58. And on the other side, 58, 58. All right, next one. All right, the following parallelogram, choose the best name. So since they're parallelograms, opposite sides are equal. So if this has one hash mark, this has one hash mark. If this has one hash mark, this has one hash mark, because opposite sides of a parallelogram are congruent. And now since they all have one hash mark, we know that this is a rhombus, because a rhombus is a parallelogram where all four sides are equal. So this is a rhombus. Okay, B, find the value of each variable. So we know in a rhombus that the diagonals are perpendicular. So we know that this is going to be a right angle. Okay, and then we want to use the fact that this is a right triangle to solve for x. So we need to do x squared plus 8 squared equals 17 squared. And then write that very nice. Okay, so that's x squared plus 64 equals 289. We subtract 64 from both sides. We get x squared equals 225. And then we take the square root of both sides to solve for x. We get plus or minus 15, but we want to get rid of the negative 15 and just make it positive 15 because it's a distance. And then if x is 15, y is 15, and then z would be 17. Right, so x and y are both 15, and then z is 17. Oops. Okay. We want to use this right triangle here, right? We know this is a rectangle because of this right angle. So since this is a parallelogram, opposite angles are congruent. So this is a right angle. We know consecutive angles are supplementary. So 180 minus 90 is 90. 180 minus 90 is 90. And so since we have four right angles, this parallelogram is a rectangle. Okay. So we know the height, AD is 7, BC is 7, opposite sides of the parallelogram are congruent. And then we're solving for z. So z is our hypotenuse. So we're going to do 7 squared plus 24 squared equals z squared. So that's going to give us 49 plus 596 maybe. 576 maybe. Let's see. 24 squared is 576. Add them together, then you get 625. Take the square root of both sides, and you get plus or minus 25 equals z. We're just going to take the positive version, right? Okay, and then if z is 25, that means each of the smaller pieces here, let me do a different color, they're all going to be the same, right? So 25 divided by 2 is going to give us 12.5, which means x is 12.5, 12.5, and then y here is going to be 12.5. So X and Y are each 12.5, and then Z is going to be 25. This is because in a rectangle, diagonals are congruent, right? And they bisect each other since a rectangle is a parallelogram. So since they're congruent and they bisect each other, that's why each one of those is going to be half of 25, half of the length of the diagonal. Okay, and then this one was a rectangle. All right, 24, quadrilateral math. So I'm going to draw a quadrilateral. Okay, I know, let me label the sides. We just use the drawing tool. M, A, T, H. Okay, I know MT bisects AH at R, so I need to draw in my diagonals. So I'm going to draw in my diagonals. MT bisects AH at points R. We know MR is congruent to HR. And that's it. That's all we know. Okay, so we know in this quadrilateral, oh, I'm sorry. Yeah, they bisect each other, right? So since they bisect each other, right? If this is one hash mark, this is one hash mark. If this is one hash mark, this is one hash mark, right? So if MR is equal to MR is equal to HR, right? That means, and they bisect each other. The diagonals bisect each other, right? We can put one hash mark on all of them, which means all four of these pieces are the same, which means the diagonals in total are going to be congruent. And since the diagonals are congruent, well, since the diagonals bisect each other, we know it's a parallelogram. And then since it's a parallelogram where all the diagonals are congruent, we know it's going to be a rectangle, right? And since it's a rectangle, it should be 1 and 2. So my drawing isn't the best, right? The drawing really should look more rectangularish, right? Where if you draw them in, right? So this is a better depiction of the diagram where all four of those are going to be the same. Okay, so this is kind of not to scale. This one would be to scale. But it's a parallelogram because the diagonals bisect each other. It's a rectangle because it's a parallelogram with congruent diagonals. All right, Cindy is making the design shown with silver wire. It consists of a rectangle and its two diagonals. How much wire does she need to use? So we need to use the Pythagorean theorem here to solve for the length of the diagonal and then add all the pieces together. So we need to do 9 squared plus 40 squared equals c squared or x squared. And call this x. All right, so 9 squared is 81. 40 squared is 1600 equals x squared. So this is going to be 1681 equals x squared. And then we square root both sides. I believe that's 41, but I'm not sure. So I'm going to put it in the calculator. Square root of 1681 is 41 equals x. All right, so my diagonal is 41. The other diagonal, since this is a rectangle, is also 41. So 41 plus 41. All right, so let's see here. We got 41 plus 41. Okay, plus 40 twice, right? We got to add 40 twice. And then we got to add 9 twice, right? So then plus 9 plus 9. So that's going to be 162 plus 18, which should be 180 inches. But our unit here is inches. And there you go.